Hi there. Hope everyone's doing well. My name's Casey. Today I'm going to be talking about building a Slackbot to manage your Raspberry Pi Kubernetes cluster. It's going to be a super exciting session. We're going to dive into some DevOps topics, Raspberry Pis, Kubernetes, all that good stuff. So I'm excited to get started. So first, a little background about me. I'm a junior at the University of Southern California. I'm studying computer science and business administration. And in general, I'm just a huge tech enthusiast and tinker. I love playing around with Raspberry Pis, coding, all that good stuff. And I was lucky enough to be a summer intern for VMware, and this was one of my projects. So we're going to start with some context, what Docker is, what Kubernetes is, how people are using Slack and Raspberry Pis. Then dive into the plan, how we came up with this idea, what we wanted it to be able to do, specifications, concerns, etc. And then the rest of it's kind of divided into two parts. So the first part is using Raspberry Pis as a Kubernetes cluster, how you can get that up and running. And then the second part is now in that cluster with Slack, using the Slack API to connect with it and pull information and all that good stuff. And then finally, at the end, I'm just going to close with some of the issues encountered, some lessons I learned, and then also some helpful links if you're interested in working on this project yourself or taking a look at what I did. So I'm going to start by explaining kind of what Docker and Kubernetes is on a very high level. So Docker is basically a container system that packages your application into different containers that have all of their dependencies included. And this has a couple advantages. A, it's highly efficient, and then B, it's also portable across platforms. So instead of needing a virtual machine or something to make everything run, your Docker containers are able to run on any hardware. But then as you scale your application, what you're going to encounter is that you have more and more of these Docker containers, and you're going to run into issues of, well, how do I figure out how I deploy them on a server, which nodes run them? And that's where Kubernetes comes into play as a container orchestration tool. So Kubernetes deploys containers as these pods, which you can see in this picture over here. And those pods are deployed onto nodes, and then the pods contain containers. So it goes container, pod, node, and then Kubernetes system or Kubernetes cluster. And Kubernetes is really dynamic in how it's able to assign those pods and how it's able to route those pods. And if a node goes down, reroute them. And that gives it a big advantage because if you're running a large service, you don't want it going down all the time. You don't want there to be hiccups. And Kubernetes just makes that container orchestration really seamless. So I like this picture over here. So you can see the master node, and that's going to have your controller, your scheduler, your cluster store, and the API server. And then you can see you have kubectl, which is basically how you interact with Kubernetes, and that's done on the master node. And then this intermediary, which is usually YAML, which stands for yet another markup language. And that's how you kind of give these definitions for how you want these pods to be deployed on the nodes. And then over here, of course, you have your nodes, your pods, and then the red is your containers, and those are created by Docker. So Kubernetes and Docker work together to build and run containerized applications. And then what is Slack? You're probably familiar with it, but it's a really popular messaging service for teams to collaborate. And more than just that, it has a really robust API, which allows you to easily retrieve information such as what messages were sent, who was sending them, channel history, all that good stuff. Pretty much anything that you could see as a human being in Slack, you could use the API to see as a computer. And that makes it really easy to build applications and bots around it and then have them deployed to your workspace in just a matter of minutes. And then finally, what are Raspberry Pis? Not the dessert. They're actually a low-cost microcontroller, usually the size of just around a credit card. They're usually going to run you around maybe $30 to $80, so still pretty cheap for a computer. And at that $80 price point, you could get pretty much a quad core with 8 gigs of RAM. And all of them have ARM architecture. So that's the CPU type, and that's an increasingly popular architecture that is really prominent in mobile computing in general. So your phone probably runs on ARM, but now more and more there's talks of ARM in actual real computers or laptops, notebooks. So it's a really exciting space to be in, and Raspberry Pis are a great way to get started with ARM. It runs a Linux-based operating system. Most commonly, there's something called Raspberry Pi OS or Raspbian. And it's basically just a distribution of Debian meant for Raspberry Pis. And that gives you pretty much full desktop compatibility. You can plug it into a monitor, you can surf the web, you can do all that good stuff, just like a Linux computer, but at that $30 to $80 price point. And then finally, it also has GPIO pins. And this is really what allow it to act as a microcontroller too, because that allows for hardware in and out, so you can plug in sensors, OLED displays, all that good stuff, and then write code to actually play around with what it's reading. So this is an example project. This is just something I worked on for the sake of this example, because this is the application we're going to want to deploy. And it takes a BMP280 sensor, which has temperature, pressure, and altitude, and an OLED display. You can see those are hooked up to the GPIO pins in the back there. It's a little faded. And then I wrote a Python app that's able to display the sensor data on the OLED. So on the OLED, you can see it's giving a readout for temperature, altitude, and pressure, and that's all being taken from the Pi live. So after I made this app, I kind of had the idea of, okay, well, what if I want to deploy it in the best way possible? Just go over the top and use Docker, Kubernetes, all that good stuff, all those great DevOps practices, and use them to deploy just this silly app I made. So my idea was I could have a Kubernetes master node as one of the Raspberry Pis, and then connect other Raspberry Pis to it and create a Kubernetes cluster pretty much, and have those be the nodes. And then after we have that, then we can deploy our sensor app, package it up into Docker, and actually be able to run it on our cluster. I thought that would be a really cool thing to kind of be able to say you did. So that's how we went down this path. So the steps here, we have to install Kubernetes and assign the Pi as master node, and then connect all the other Pis to the master node as the worker nodes. And then we have to use Docker to containerize our app, because remember, Kubernetes isn't going to run without those Docker containers. And then finally, create that YAML pod definition that I was explaining earlier that Kubernetes needs to understand the parameters of how it should run its nodes or its pods. So before we can kind of get set up with that first step of getting Docker and Kubernetes on the Pis, there's a couple things you have to do if you're just getting started from the get-go. And that's flashing Raspbian or Raspberry Pi OS onto an SD card, setting a static hostname and IP address. That's pretty important, because without a static hostname and IP address, it's going to be really hard to join your worker nodes. And then finally, we can get to installing Kubernetes and Docker on your Pis. And I've actually written a blog post about this that can be found on VMware Code, and it has a lot more in-depth instruction and scripts if you want to actually follow along and do this yourself. So after we've installed Kubernetes and Dockers, we can initialize our cluster with just the command sudo kube80 init, and that will print out kind of what you see on the right over there, and say your Kubernetes control plane is initialized successfully. It'll give you a couple instructions there to make sure that the configuration is proper and the folder system's correct. And then finally, it'll give you a join command at the bottom, which is circled in red. And that command is what's going to allow you to actually join using your other Raspberry Pis and connect them as worker nodes. But if you just connect them as worker nodes and you don't apply a container network, they're not going to be ready. You're not going to be able to deploy anything or deploy your application to them. So before we can actually deploy our app, we actually need to install a container network. And the one I chose to use was Weave, but there's many like it. Flannel is another good one, but I just found Weave to be the easiest. And you can do that by just doing a kubectl apply and then just this file name from their website. Basically, what a container network does is it connects together all of your nodes and makes them ready for containers to be deployed on them. So that's a really vital step, and your status of your nodes is not going to be ready until you actually deploy that. So now we're ready to move on to packaging the application into Docker. And the most important thing here is what's called a Docker file. So that's just pretty much a text file, and it gives Docker the parameters of how it should build and package your application. So you start with the from, and that's that first line there, and that's pretty much specifying the architecture of our CPU and then also the language that this is written in. So it'll first pull all of those dependencies, and then all of these run commands are actually just commands that are ran on the Pis themselves, or on rather wherever the Docker file is being built. And so the reason I included these are because these pretty much just cover all of your dependencies. So for example, to use the OLED display in my app, we needed to use Pillow in Python, which is a graphics application or library. So I run pip install Python. The sensor is made by Adafruit, and they have a great library for it. So we had to run pip install Adafruit, SSD, whatever. And then finally, at the end here, you add your executable. So that's saying that this is going to be added to our Docker file. And then you run the command, and the command just to run any Python file is just Python and then / whatever the Python file is. What this Docker file is doing is it's pretty much just telling it exactly how the application should be packaged, and then Docker will handle how to build the containers from there. You basically just tell it what it needs, and then it'll handle the rest. So after we do that, Docker and Kubernetes are super integrated, and one of the reasons why they're so integrated is because of Dockerhub. So first, we're going to build a Docker image, and that's pretty simple. It's just a Docker build, and then -t, which is a title flag, I think, and then just whatever you want to call it. And then just to make sure that's running correctly, you should just run it. And because our app uses sensor data, that's actually something that's privileged to the user. So we have to run it in the privilege mode with that flag that you can see right over there. And then if that's all working correctly, it means you've successfully created a Docker image with your application. Now you're ready to upload it to Dockerhub. So like I was saying, Docker and Kubernetes are super integrated. And one of the reasons is Dockerhub, which basically means that in a Kubernetes YAML file, in your pod definition, you could specify a, a Dockerhub repository that you want to pull your image from. And all you have to do is give it kind of your username / the repository name. And it's really easily able to pull that from Dockerhub and then deploy that as your application. So you don't even need to have things locally. And that again, just is another kind of way that Kubernetes and Docker makes that development process easier. And then Docker also has integration with Git. So you can kind of go through all those 3 stages there super easily, going from development in Git to containerization in Docker to container management in Kubernetes, just in kind of 3 seamless steps. And then after, so to upload it to Dockerhub, we do Docker login with your credentials, and then you tag it. And the tag is pretty similar to what a commit is in GitHub, or a commit message. So it's basically like usually a version or like a list of what's different about that compared to your previous build. And then you just push it to your repository name. Again, these 2 steps are pretty similar to how GitHub would work, but just Dockerhub. And then we're ready to get to the deploying the pod part. And this is in YAML, yet another markup language. And this is basically what's going to give you all of that, give Kubernetes all of that information of how it should generate the pod and which node it should assign the workload to, all of that stuff. So YAML files, this is a pretty basic one. Obviously, as you deploy crazier and crazier things, they're going to get a lot more complicated, but this is a pretty basic one that will deploy just a pod named BMP display, and it will run it on the node name that you specify. So whichever Pi you want it to be ran on. And then it will also pull that image from VMware code /BMP280 v1. And that is just a Dockerhub link pretty much. So it automatically knows that, okay, if it's in this format, we should be pulling it from Dockerhub. And then the rest of this is pretty much security context. And that's basically telling it that it needs to run in privilege mode, because as I said before, using that sensor information means that you're going to need full access to the hardware you're running it on, which is why we need to make sure that we're an admin. And then, now that we have our YAML file, all we have to do is just run kubectl create -f and then whatever we call the YAML file. Then the pod should just be up and running. And you can see to the right, that's an example of how those pods are going to look when they're up and running. And that's what happens when you type kubectl get pods. So there's 2 main commands there: kubectl get nodes, which shows you the status of your nodes, and then kubectl get pods, which shows you the status of your pods. And that's pretty much it for the first part of getting Kubernetes set up on your Raspberry Pi cluster. So after I had this done, I thought it was pretty cool, but I was like, okay, let's say I want to be able to access that information from kubectl get pods, kubectl get nodes, but somewhere else. Maybe I'm on my phone somewhere, maybe I'm on my laptop somewhere, I'm not quite at home. And I thought, well, wouldn't it be cool if maybe I could connect that with the Slack API and then be able to call it anywhere pretty much and see how things are running and get some output. So kind of the 4 main parts here that we needed were: 1, the Slack API. That's what's going to allow us to read messages and post in our Slack channel when added. So my idea was you could add the bot and say, hey bot, get pods, and it could tell you kind of everything that you would see in the console, but in Slack. A language, I chose C++, mainly because I was just familiar with it. And then a library for the language. And the library is what's going to allow us to talk to the Slack API using C++ and then receive information back in C++ from the Slack API. So I chose Slacking. It's the main C++ library for Slack. It's pretty lightweight, and it allows us to write C++ code and then also parse what the API is returning because it has a JSON header file built in. And the JSON header pretty much converts the JSON formatting into C++. I'll explain a little bit more about that later, and hopefully it'll make more sense. And then finally, the functionality that we wanted from it. Like I said before, just getting that information about nodes and pods was my main idea, just to be able to see, hey, is everything running okay? Did a container go down? Did a node go into a not ready state? All that good stuff, and just being able to see that from anywhere. Okay, so now getting information about Kubernetes into C++, I use this pretty basic structure of object-oriented design kind of. So I created a cube object, and that would have a list of node objects and pod objects. And then the node objects would hold a name, status, role, age, version, pretty much all the information you'd get from if you ran get nodes. And then the pods would hold name, number of ready pods, total possible ready pods, a status, number of restarts, and then also an age. And then to actually extract the information, my program SSHs into the Pi and is able to just run a system command and then parse from there into these using various functions. And like I said, all this code is included. I'm not going to dive super deep into it right now, but you can definitely check it out on my GitHub page. I'll include that link at the end. So after I built that out, then it was time to start integrating it with the Slack API. So I was able to pull Kubernetes information into those objects, like I was saying, but now I wanted to be able to output that information into Slack. And the way I did that is just by creating a Slack app. After you create a Slack app, you're going to get a bot user OAuth access token. And that bot token can be used to create a Slack instance within the C++ library, like I was talking about. So this Slack : create, that's the main command to create a Slack instance using this library. And once you create one instance, it actually is global. So that instance will carry through. You don't actually have to call this every time you use it if you're in another scope, which is pretty nice. And then we have to set up some permissions for it, basically telling the bot what it is and what it isn't allowed to do. So these permissions that we have to set for purposes of this bot is it should be able to see our channel history, it should be able to write to our channel, it should be able to see our group history, IM history, post messages to specific channels using incoming webhook, and then also be able to see group and direct messages if it's been added to those groups. So yeah, there's three main steps here for calling the Slack API for information. So we're going from our C++ code, and in the code, that's where we make that API call. So you can see here, we call that Slack library, Slack : post, and then this is just a JSON format of an API call. So we make that Slack API call, and then Slack in return sends us back a JSON response. And that JSON response for this call, for example, so this is conversations history, and I'm telling it to get the history of this channel ID. And then I'm saying I only want the latest one. So I only want one, and that's the limit, and that's going to give me the latest message from a channel. And then you can see you have in response, it'll tell you, so first it'll tell you if it went okay, then it'll tell you information about the message, so the type, the user, the text, and then the timestamp. And then pretty much just everything you'd ever need to know about how the message was sent. And then you can manipulate that information however you want to send stuff back using conversations.message, conversations.postMessage actually. And yeah, that's basically the Slack API in a nutshell there. So the result of kind of putting all of these steps together is the bot works, and it's able to take that information from Kubernetes, output it onto your Slack channel. So as you can see right there, I'm calling get nodes, and then it'll tell me the name, status, role, age, version. Get pods, it'll tell me the name, number of ready, total ready, status, number of restarts, and age. And then also while I was at it, I added just some fun chatbot features. You're able to make a rules file, which pretty much just is like an if this, then that. So you could say like, oh, when's my birthday? And then have it programmed to say, oh, it's November 15th. And then some closing remarks here. Using C++ with the Slack API really wasn't the best call. I did it just because I was the most familiar with it. That's kind of what I've been taught in school for a second now. but it really made things more difficult in a lot of ways, just because nowadays a lot of developers are building really great libraries in Python and Ruby around the Slack API. And instead of having to call manually the Slack API with the JSON, like I was doing using the C++ library, I would have just been able to kind of use these abstracted methods that people have created to do a lot of the functions that I wanted to do. And then finally, some links here. If you're interested in checking out the code for the Slackbot, I've listed it in my GitHub page. So it's github.com/KesiSoundUSC/Kubernetes Slackbot. And then also, if you wanted to learn more about that first part of the presentation where I was talking about building a Kubernetes Raspberry Pi cluster, I have a blog post on that, and that's on the VMware Code blog at blogs.vmware.com/code. And then, yeah, you can, I guess, fill in the rest there. Thank you very much for listening. Take care.